All right, students, I'm going to try another video solution here. This one's number 23, and it really follows from 22. So I hope you take a moment here and watch 22 first. And this is all the work I did on it, and we found the person's near point, at least their near point, if they were going to wear contact lenses, because that's what 23 is getting at. It says repeat the, excuse me, repeat the previous problem, but this time we're going to wear glasses. And what's absolutely crucial in this is that we realize that the glasses are going to be in front of your eyes by a distance of 2.2 centimeters. And so the picture I drew with the eyes and the contact lenses, now we're going to have glasses here. And the glasses are going to hook over the ear. But there's going to be that slight extra distance. And that distance in number can become significant. And that's what this set of problems hopefully illustrates here. All right, so when it says repeat the problem, we'll come back up here. And the problem says that a child sees that their prescription is 0.75 diopters. And it asks for the near point. And so, like I said, hopefully you've watched already 22, but I'll just go and write down this equation. So 1 over object distance plus 1 over image distance equals 1 over the focal length, and 1 over the focal length is then the power of the lens, okay? And in this case, the power is the 0.75 diopters, which I'll write as inverse meters. So all my units will be in meters here. And then I'll go through here. But here's an important difference. And so maybe I'll come back to this picture. We want to give this child a prescription for their glasses so that they can see things that are 25 centimeters from their eyes. Now, please remember that being the glasses, or the lenses of the glasses, are 2.2 in front of their eyes. So our equation here, when we talk about object distance and image distances, these are distances from the lens itself. And so my point is then, and I'll just write this down here, the object distance is not 25 as it was back in problem 22. See, back in 22, I actually just put a distance of 25 because the distance in front of the eyes was the same as the distance in front of the lens when you have contact lenses. But when you don't have contact lens, there is a slight difference between those two. And so our goal is to get the child to be able to see clearly when things are 25 centimeters from their eyes. Okay? So if I go 25 centimeters and I subtract 2.2 centimeters, that make 22.8 centimeters. And of course, doing things in meters means 0.228 meters. So for this particular problem, we're talking about putting an object that is 0.228 in front of the lens, and again being 0.25 in front of their eyes. And so now if we go to solve for image distance, and maybe I should just be a little careful here with the math. I already have the 0.75, but when I bring this over, it's minus, and if you'll let me write then the reciprocal of that. And technically that by itself would be 1 over the image distance. So I need to take the reciprocal of that. Okay, so this is going to make an image distance of, let's see in the math here, 0.75 minus 0.228 reciprocal. I'll just hit enter, okay. Then I'll take the reciprocal of that. And so we're talking about an image distance of negative 0.275. Or if you would like, negative 27.5 centimeters. Now, again, I'm not done. Coming back to maybe this picture, here's what we've just done then. Well, we've taken an object that's actually 25, and after going through this lens, the glasses here, it's making it look like it is out at 27.5. And notice the negative, so it's out in front here. But also, that number, image distance, is measured from the lens. And so just like back here in this problem, we had to be a little careful and make sure that when we talked about object distance, we were talking about from the lens. And that's what makes, I think, this problem, number 23, a little bit harder than 22, is because we have distances from the lens, but we also have distances from the eye. And so this 25 was from the eye, but we needed to calculate from the lens. And now when we got this far, we've calculated the image distance from the lens, but what is that from the eye? And so if we put another 2.2 on here, we're looking at about a 29.7 centimeters. And so this would work, that is, this power of lens on glasses that are 2.2 centimeters out would work great if this person's eye has a near point of 29.7, because it just made something that was 25 from their eye now appear to be 29.7 from their eye. And then that's what their eye can naturally do. And so that's what you would want. Now, to be quite honest, I mean, we're working backwards. If we were an optometrist, we would actually measure the near point, and from that then calculate what the power of the lens would be. That's your prescription. But in this case, as the problem says, we're kind of working backwards. We're using this, I guess, as a learning opportunity. Say, hey, why'd you miss class yesterday? Oh, I missed class because I had to go to the doctor. Oh, you got a prescription. Can I see your prescription? Was it glasses or was it contact? And then you can work backwards and figure out what their near point would be. All right, well, hopefully that was helpful also. Take care.